We've got a particle in straight line, just like it says in the learning goal, given by this. No worries. Where v is a velocity at time t, body's at rest at the origin at time 0. That's useful information. So we're going to figure out these three things. So let's start with velocity as a function of time. What should we do? So we want velocity in terms of time. So we're going to flip it. Why do we flip this? To get the dv's with the v's. So we're going to flip both sides. So flip the fraction on both sides. We're going to bring the dv over. So it's just, or multiply both sides by dv. Then what? Integrate both sides. Integrate 1 dt. It's an invisible 1 there. What does that become? Integrate 1 over v plus 1. It's underneath a fraction. The power is 1, so it's natural log. You okay? Don't forget the plus c. You are worthy of calculus if you remember the plus c. So we want v as a function of time, so we're going to try and get v by itself. So bring the constant, the unknown constant, across. And how do we get rid of natural log? Yep, do the exponential as the base, which eliminates the natural log. So you're just left with that. Yep, so we don't really like that minus c, you guys are used to this. So we can turn that into a, where e to the negative c is equal to a. Bring the 1 over, and we have v by itself in terms of time. Anything else we need to do? We probably want to know what a is, yes. So is there any information that could help us find that? The body's at rest when t equals 0. So that is called a initial conditions, or a particular solution. When t equals 0, v equals 0. Is that okay? 0 equals a to the times e to the power of 0 minus 1. Therefore, a is 1. You got it right. Good job. Like a pro. Usually guessing doesn't work, but that time it did. Good job. Part B. You can do it that way as well, yes. Let's see if we get the same answer. So what's the differential of that? ET. Yay! That was tricky. And we started with v plus 1, so if we subbed in that into v plus 1, another method, we'd end also up with e to the t. So two different methods. Just differentiate or sub what you got into the original. Both gives you the mark. All right, let's try C, position in terms of time. What do we do now? Integrate velocity. So position, position in terms of time is equal to the integral of velocity dt. So e to the t minus 1 dt. The integral of et is et. Like my poke, come on. Oh, it's over there. I used integrate. It's not effective. All right, -1, integrate that. It becomes -t. And plus c, you are worthy. Well done. And what conditions can we use to find the c? Started at the origin, so the position is 0 at time 0. So c is equal to... Oh yes, correct. -1. Good job. E to the 0 is 1. So C, I was jumping ahead. There you go. Don't jump ahead. Rookie error. I should also communicate the conditions I'm using. And that's about it. Any questions? Sub back in C equals -1. So if this was a force question, you could just turn this acceleration into a force by timesing it by some sort of mass.